like a cake sliced into squares and rectangles.
To me, it looks like a woman's bandana or a man's handkerchief.
I see 3 squares and 6 rectangles of different sizes.
3 squares? Don't forget the biggest square that surrounds the whole figure.
Actually, you're all correct. Paintings show geometric shapes, which are also algebraic expressions.
Algebraic expressions? I don't see any numbers.
Nor letters. How can that be?
You'll know soon enough. That's our lesson for today. Algebra works with symbols, numerals, and letters, which stand for quantities, which in turn form meaningful expressions. Algebra is sometimes referred to as a shorthand way of writing ideas. One of the simplest and most common expression is a polynomial. Can you think of words that start with the prefix poly?
Polysyllabic. Polysyllabic.
Polygon.
Polyglot.
The meaning of poly is several or many. Other prefixes which you come across in everyday language also includes mono, bi, and tri.
Saluhin mo ba ako yung pag nahimatay ako? Hindi. Anong gagawin ko pag nakita ko siya pag pinakilala niya?
Monologue.
Tatakbo ba ako?
Bigamy.
Triangle.
Tripod.
Monotheism.
Bicycle.
Can you infer what mono means?
Yes, it means 1.
And the prefix bi implies 2.
Very good.
Then tri would mean 3, as in the tricycle I ride in every day has 3 wheels.
If monomial in algebra means one term, what does binomial mean?
2 terms.
And what do you think trinomial suggests?
3 terms.
Very good. Polynomial suggests many terms. However, to simplify things, the term polynomial could refer to algebraic expressions with one or more terms. When one wishes to stress the number of terms, we use monomial to refer to an expression containing one term, binomial for 2 terms, and trinomial for 3 terms. Beyond 3 terms, in fact, using one or more terms, it is mathematically correct to use the general term polynomials.
Excuse me, sir,
Yes.
but what's a term?
A term is a number or an indicated product of a number and a variable. Polynomial terms are separated by a plus and minus sign. These signs indicate addition and subtraction. For example, 3x squared is a term. It is the indicated product of 3 multiplied by x squared. X squared is the indicated product of x multiplied by itself. X times x equals x squared. In 3x squared, we call 3 a numerical coefficient. X is a base and a literal coefficient, and 2 is the exponent of x. The exponent tells how many times the base is multiplied by itself. In the term 4x cubed y, 4 is called the numerical coefficient of the term. X is one of the 2 literal coefficients. Y is the other literal coefficient. 3 is the exponent of the literal coefficient x. 1 is the exponent of y. An exponent of 1 is usually not written. When not written, it is understood to be 1. A polynomial in x is an expression of the form a sub n, x raised to the n, plus a sub n minus 1, x raised to the n minus 1, and so on, plus a sub 2, x squared, plus a sub 1x, plus a sub 0, where a sub n is not equal to 0. Note, however, that a's are real numbers and n is a non-negative integer. Let me give you some examples of polynomials. Can you tell me how many terms these polynomials contain? 2x plus 5. Carla?
2 terms, a binomial.
That's correct. But next time, try to be sure of your answer. What about 3x squared plus 7x minus 5?
3 terms, a trinomial.
Very good. 5x cubed minus 7x squared plus 2x plus 4.
4 terms, simply called a polynomial.
And what are the coefficients of the last polynomial, Mia?
The polynomial 5x cubed minus 7x squared plus 2x plus 4 has coefficients 5, negative 7, and 2.
I noticed that the polynomial is written with descending powers of x.
Good observation. That is called the standard form of the polynomial. In a polynomial, the term which does not contain the variable, which in our definition is a sub 0, is a constant term. Note that in the definition, all exponents should be integers. For polynomials in more than one variable, the degree of a term is the sum of the powers, or exponents, of the variables in the term. The degree of the polynomial is the highest degree of all its terms. 5x squared is of degree 2. 5xy is of degree 2. 5y cubed is of degree 3. 4x squared y cubed is of degree 5. The polynomial 6x cubed y plus 3xy squared is of degree 4, which is the degree of 6x cubed y, the term with the highest degree. To be in standard form, the polynomial should be written with descending powers of x. This way, the degree of the polynomial is easily seen. Examples. The coefficient of the term with the highest degree is called the leading coefficient. So we can simplify the definition of a polynomial as a sum of terms, each of which is a product of constants and variables raised to whole number powers. In a polynomial, a variable cannot appear in a denominator as an exponent, within a radical, or within absolute value bars. Now, which of these are not polynomials?
Number 4 is not a polynomial because the variable x has a negative power.
Okay.
Then number 7 isn't a polynomial either because the variable x has a negative power.
Number 5 is not a polynomial because it is with a radical.
Number 8 isn't a polynomial because the variable is under the division sign.
You're correct in saying that number 8 is not a polynomial, but don't confuse the fraction bar as the division sign. When the variable is in the denominator, the number is not a polynomial.
Number 9 is not a polynomial because the variable x is an exponent.
Number 10 isn't a polynomial either because the variable x is within absolute value bars.